Beginning. So this talk is about the project OWASP Amass, which is does network reconnaissance and open source intelligence. And this presentation, excuse me, is focused on showing you what this can do, and hopefully a little touch of where we're going with it, and opening up discussion around that. Little quick bit about who I am. So I'm the project lead for OWASP Amass. I'm also the purple team manager for National Grid. And I've done this kind of work for quite a while. You can find me at these two places on the internet. We also have some other places that this project exists, like our Discord and things like that. If you have ideas that come out of this discussion and you want to talk with us more about it, please feel free to become more part of our community.
I'm Anthony Rhodes. I'm recently a contributor of the Amass Project. Also recently became a senior purple team member at National Grid. I have been doing pen testing for I think 5 or so years. And yeah, I can be found on Twitter, GitHub, Discord, all the things. So.
Forgive us, I think we're going to be playing with this thing a little bit. See how well we juggle it. All right. So like I said, Amass is a network reconnaissance tool. When this got started, I guess you could say it was subdomain enumeration. It's definitely grown into more than that now, and I hope you'll all see that by the time we're done. But what it really, I think, means for organizations that are using this is it's automating all these techniques that typically are being done manually or with separate tools to map your organizations or any organization's attack surface on the internet, or to understand the exposure of an organization on the internet, perhaps would be a better way to say it. And what's so powerful about this, once you start using it, is really it's all the data you end up collecting from it. So we try to provide that data in a lot of different formats that make it useful to different audiences or users. Like one of my favorites is Maltego. You know, I love being able to do this and then see the whole entire network come alive in front of me. But really the graph databases are probably the most powerful data source that it creates. Since we're just getting started, honestly, with what we can do with that data. I threw this up here immediately just to show you that unlike some of these capabilities where you just get a bunch of text coming out and you have to go through still the work of making sense of all that and deciding what you want to do with it. I mean, I'm a very visual person, and I find it empowering to be able to just see what was discovered and start doing some like exploratory analysis on it to start deciding where I want to dig deeper. This is just one of my favorite visualizations. Came out of I would say, medium-sized target. But I thought it looked kind of nice, and some of them do. So I threw this slide in here. I want to talk about, in a lot of ways, this is becoming more, again, than just subdomain enumeration or just a piece of a pen tester's job to understand an attack surface. So many organizations that I engage with, when I ask them, do you know what you look like to an attacker? Their answer, it seems like almost always is either no, or well, maybe not completely, or we don't have that all documented. But usually the answer is they don't. They don't know what they look like if someone like myself or others were to say, you're in the crosshairs. And if they wanted to, and they wanted to put funding behind this, it's getting harder to do this with the use of third-party services, the cloud, all these different ways that you can be fragmenting your exposure or your attack surface. It's getting difficult to stay on top of this with all the different teams that are involved in creating exposure and then not documenting it properly. And it's causing more companies, I think, to have to use OSINT as part of their almost like asset management program, which is interesting. But that's one place where I see people practically desperate for this kind of capability. But of course, it's useful to so many other groups as well, which we talk about later. But that's really the interesting thing that I learned from this project is when I started this, it was all for me, honestly. It was just something that I wasn't getting enough from what was out there. I created something that did what I needed to do because I wanted to be able to answer this question for myself: is that organization, what do they look like? Do it for me. I don't want to sit here and do it all day. But I'm engaging with organizations and finding out there's a bigger need for this, or larger need for this. So one thing I'm not sure I said yet is we've tried to make this presentation so that you're not listening to me the whole time. Instead, you're going to be seeing what this can do. We have a lot of demonstration video content to show you. But I want to talk about first, what should you be maybe thinking about as the workflow for using this? Or that could, of course, vary depending on how you use it. But I'm going to, I guess, start with all the way at what could be the beginning to the end. So you can see how this tool suite can handle your entire investigation, whatever that means to you. And it's spread across, at this point in time, it's about 4 different tools. Not necessarily, the end of the story, but that's what it looks like right now, which are these right here. I put a little summary here just so that when we're talking about this, you'll know what are the dividing lines kind of between these tools. The point of net domains is to go from information you could have, like an organization's name, details about their networks, ASNs that they're on, or ASs for that, forgive me, and then come up with domain names, because the Amass proper tool pretty much just takes domain names and then gives you infrastructure, I would argue. And then from there, visualization tool, we've seen what that can do. And the tracker is what allows you to watch what's changing between your observations or enumerations. All right. So this is where So Anthony's going to show you some of these.
There we go. All right, so first I'm going to go through net domains. So say you're not given a scope, you just know, the organization name. You don't know any domains, IPs, ASNs. So let's see, can I just hit space or just clicking? Loading. Okay, there it goes. Okay. All right. So for this example, we just gave the organization name Utica College with the -org flag. That gives us the ASN information for any ASNs they own. Then we take the ASN number and pass it through the ASN flag, and then that should give us some domains that are associated. I think it'll be done soon. And then there's okay. There's also whois capabilities. So that does, I don't know if anyone's familiar with reverse whois. There's a number of services out there that will actually collect whois information, and then you can search by some of the registration information, like the registrant email address or the registrant organization name. So what this run of the command is doing is it's calling out to one of those services and then giving you all the domains that are registered by the same person. So now I'm showing off just, you know, that's way too fast. Okay. So I resolved one of the domain names, got an IP address, and then did a whois on it to try to get the entire net block, because Utica College owns the entire net block. And then you could also use that to, you know, pass it back into the program to get more domains based on the IP addresses in that net block.
Or it can serve as an alternative way to get the same information.
Yep.
Or whichever you prefer.
Yeah, it really depends on, you know, what information you're starting with, and this is just showing off all the different, I guess, entry points. So yeah, I think that's it for this one. Next slide. Okay. So now we're moving on to the Amass tool. Is it playing? Uh-oh. Back. This finicky. Hey. How big did I play it before?
Try right-clicking it, actually.
No. All right. You said you copied the videos?
Yeah.
Yeah. Okay. I'll just do that then. This. Okay. Cool. No. How does PowerPoint play it? All right.
Yeah.
Can everyone see this? Well, I have a play button here. Oh no! Get out of here.
Say it. Try it.
It takes forever. I did this on my laptop yesterday, and it took. Oh, come on. Ooh. Our savior.
Never goes purple, right?
Oh yes. Okay. Oh.
Yeah.
Wrong one. There. Yes. Okay. Back on track. Okay. So Amass has a number of modes you can run it. This is the passive mode. You just give it a domain name, and it'll go out to a bunch of you know, OSINT data sources and pull whatever domains or subdomains that they have for that domain name. And then, so I guess I can talk about some of the sources it pulls from. CertSpotter, HackerTarget, CertSH, DNSDB, yeah. There's like over 15, I think.
Certificate transparency sources.
Yeah. I think this is, yeah, it doesn't give you any more. Okay, yeah, and then at the end it gives you just a summary of, what types of data sources were pulled. So you can see like there's some cert, archive. Oh yeah, that's a big one. We pull from web archives and kind of crawl pages to look for subdomains. I guess we'll move on to the active one. Okay, so the active, okay, let's back up for a second. So there's a config file you can give Amass that allows a little more configuration to the tool that you can't find in the command line tool flags. So in particular, the alterations min for word flip isn't implemented as a command line flag yet. So, but also you can add a bunch of things like API keys, because there's a lot of data sources like Cisco Umbrella, VirusTotal, that you can throw in an API key and it'll pull subdomain data out of those. So yeah, and so for this run, I have brute forcing. I'm specifying a custom word list. The active mode also reaches out to some of the IPs and tries to pull a cert. So you give it the port. Oh yeah, and it also does DNS zone transfers. And then we're going to enable alterations, which we'll explain later. And yeah, we're going to do it on OWASP.org. So yeah, and the dash source command line flag gives you this which data source each particular subdomain came from. See like cert spotter. And then dash IPv4 just prints out IPv4 addresses. So a big difference too from the passive compared to the active is that the passive mode doesn't do any DNS resolution. So if you want IPs, you can't use the passive mode. So yeah, you can see it does brute forcing, and a major part of the architecture is everything almost feeds off of everything else. So when a data source finds a new domain, subdomain, it'll try to resolve it. If it resolves, then it gets fed back into a number of any other of the data sources so that they can try to generate new names off of that. So like brute forcing, for example, if you have like OWASP4.OAuth.org, it'll try brute forcing subdomains off of that. Yeah, and as you can see, it's pretty fast. That's actually slower than we usually see. Yeah. Yeah. And then at the end, it's like the passive tool. It tells you which categories they all fall into, but it also gives you a lot of the IP and ASN information that it extrapolates from the IPs that it resolves. And then we're going back into the slides, right? Okay. The video's working. Now we're going to talk about the internals.
Yeah, so, excuse me, Anthony covered this a little bit, but so we kind of break these functionalities or pieces of the architecture into what we call data sources for most of where we're getting all this. But we also have some other techniques, like we call it alterations, which is creating permutations of the names or trying to guess new names. And brute forcing, there's a handful of these things that we we see as generating names that then need to be resolved, or we need to query for these names. And as he already said, a lot of this gets fed back into these same sources or techniques. So for instance, all the resolved names go back into the web archive data sources, and they all use those as potential new targets for crawling new pages to get more names. Brute forcing uses the subdomain proper names to then do recursive brute forcing. And alterations, takes all the names actually and considers them for making modified versions or to create. We even have, well, we'll talk more about that in a minute. So we break the techniques into these categories. I think maybe DNS could have been up here because really there's so much that we get just from DNS. But yeah, we're definitely doing scraping. We're using REST APIs, some of which require API keys, DLS certificates, web archives. It's pretty standard, but that's what you're seeing when it tells you what types of sources came up with this information. Actually, I was going to have Anthony talk about a lot of this since he rewrote some of it recently.
Yeah, so alterations, it'll basically look for common patterns in subdomains that Amass is enumerating, and then try to modify it in ways that will generate more results. So for example, if it sees like test1.owasp.org, it's kind of hard to see, but it'll try replacing the number with 2 through 99. And then if there's like keywords like dash prod or dash test, it'll try switching those with other common words like QA and UAT, origin is common for like CDN stuff. It'll also try adding those keywords to just normal subdomains, like test.owasp.org will turn into test-prod.owasp.org. And then there's also kind of like a fuzzy alterations engine that.
Yeah, question.
I'm sorry.
Can you generate your own dictionary that you can drop into that in order to improve your accuracy or your resolution as you go through the different variables?
Right now, the dictionary. Oh, yeah, sorry. He's asking if you can specify a dictionary for the keywords and variables for the alterations. And the answer is not yet. Currently, it's hard-coded, but we took a lot of lists, like common lists from other tools and other sources, just experience too. So yeah, there's also an aspect to it where it like tries to look at the word and switch characters, and then just recently we added the predictive name guessing using Markov models. This is where I give it back to Jeff because he wrote that.
Yeah, not that it's exactly rocket science or anything, but as more of these names are discovered, it takes the names and then uses, it breaks it down into n-grams. So I guess any of you can go dig this up if you're interested. It's very similar to how password cracking works, where you break it up into pieces and say what characters tend to come after what pieces, and start building probability around this. And then when the more of this data you collect, or training data essentially that you have, the more accurate your guessing could become. And the idea, what this addresses that some of these other techniques did not, is that it finds very similar yet just a little different names. Like the fuzzy, I don't think we have it in here, but we have another technique called, I call it fuzzy label searches. It does a little bit of this where we have a very small edit distance, and we just make small changes to the labels and see if we get hits. But it doesn't quite do what the Markov models does, which allows us to see more like patterns that are showing up and say, okay, so based on what we're seeing more of, give us more of that, but with differences, and let's try it. And it tends to hit things that the other techniques just don't. So we kept it in there. And obviously with that particular technique, the larger the namespace of the target, the more accurate your model becomes and the results get better. All right. Oh, back to Anthony. Like I said, juggling.
Yeah, just right before I get into this, I did want to mention the config option that I showed off before, min for word flip. That's the minimum number of times that Amass has to see a certain keyword after a dash before it attempts to try it on everything else. So if you set it to 0, it'll try it on all new names. But if you set it to like 2, it has to see it twice before it'll try it. And that's just a way to reduce the amount of DNS queries you're doing.
I want to tell them about how brute forcing is similar with min or recursive.
Oh yeah. Yeah, so the min for recursive flag is essentially very similar. It just specifies how recursive needs to be before.
Well, it's how many labels have to show up on that subdomain before recursive brute forcing begins.
Yeah. And onto the visualization. Just gonna do cool. Yes, he's already up. Okay, so Amass stores all its data into a database, a graph database, and the Amass Viz tool will then pull that data out, and it can generate a visualization. In this case, I'm doing the D3 visualization, which is everyone, if anyone's familiar with the D3.js library, that's what it does. And it's going to be, in a few seconds, it'll show up. There's going to be a graph that shows essentially the internal state of how it's all stored. So you can see here the big red dot in the middle is the domain you started with. The yellow dots I think are pointer records. That purple dot's AS, and then it goes to NetBlock, addresses, MX labels. There's another domain. And then the green are subdomains. So this is a good way to actually visualize, I guess, your external attack surface. In our experience, like sometimes, maybe as a result of an acquisition, there'll be like a huge blob, kind of off the rest of the graph. So this is just an easy way to visualize that. And also you can see like there's a lot of strands that come out. Those could be different cloud providers. Let me just back it up. Okay, like I think like one of these was DigitalOcean, another one was Google because they use Google Mail. So yeah, just a really easy way to kind of explore through the data. And there's also different output formats. You can, I'm blanking. What are the different output formats?
Yeah, they're
I use D3 the most.
There's Viz.js, D3, Graphistry, Maltego, the one that starts with a G that's written in Java, JEXF format. I can't think of the name of the tool off the top of my head, but popular visualization format.
So yeah, speaking of the Graphistry visualization, this is an example. This particular visualization has over 30,000 nodes. So as you can see, it might be very difficult to just manually sift through that data. But looking at it this way, you can definitely see patterns and just like how some are related to others.
Two things about this. I mean, most of these other formats, they don't do very well rendering 30,000 nodes. So Graphistry is a rather special service in that it can handle that. The other thing is, you know, to Anthony's point about, so well, why even look at this, or what does it do for you? It's the structure, I would say. Again, back to what I said in the beginning, that could give you leads as to what here looks interesting to pursue further. It might actually be the smallest pieces, you know, the pieces that are clearly not the main part of their network, but the dependencies that they have. It'd be a lot easier to figure out what those are using something like this than to go through all the data yourself.
Now we're going to go over the tracker tool. So the tracker tool shows off. I thought I minimized. There we go. Okay, so the tracker tool, because we store that data in the database in the Amass output directory, every time you run an enumeration, that database is going to be updated with new enumerations, and then the tracker tool will be able to show you the differences between all those enumerations. So the default view is just the latest enumeration you did compared to every other one previous. So you can see here we ran two OWASP.org enumerations, and the only differences are a lot of these you know, third-party services, like I think they use Google Mail and Google Docs and things like that. So you can see, because they're all cloud resources, their IPs are changing all the time. So yeah, and it'll show additions and removals too. Just that there's not a lot of movement on OWASP other than those cloud services. Then there's also a history feature. Okay, and that'll show you the differences between all of the previous enumerations, so you can kind of get an idea of the timeline, like how an organization is changing. Say you run this every week, you can get an idea of how an organization changes week by week. Do you have slides to? Okay. So this is just going to give you an idea of use cases.
Yeah. So, as I mentioned earlier, when I first started this, all the reasons for doing it were just driven by myself, but quite a community seems to have built around this and people that are using it every day. And they're from all different kinds of teams. Blue teams that are trying to keep track of their exposure, you know, red teams and pen testers, as you can imagine, that are just trying to find more opportunities. Same thing with bug bounty hunters. They keep telling me how all the time this is saving them because now they don't have to do this themselves or write their own scripts to automate using lots of tools and hoping that they can get all the data to come together. But also, the OSINT community seems to like this tool. Investigators, threat intelligence, you know, without getting into too many details, I mean, you can imagine hunting down people on the internet can be a lot easier, of course, if you could actually know what they look like or what they're, well, for instance, I mean, with all these tools we've shown you, you can watch the campaigns of operations unfolding. I mean, you can you can keep watching someone's network where they're performing these activities, and you can see what they're doing. You can see them setting up for upcoming attacks. So, I mean, I would say it takes predictive or preemptive methods to a whole new level, kind of, because it's like having a scout that is actually watching this. Whereas if you're only going off of feeds where someone else is saying, well, we think this is happening or it's likely, I think it helps to be able to say, well, we're seeing it too. We're watching the same thing, and we can map it to what these feeds are telling us. So yeah, if you would like to play with this, you can go to the project page, see what we've done with this and where we're going with it. You can go get it at the repo at OWASP Amass. And if you're playing with Kali like so many other people, people seem to find it easier to install this using Snapcraft, even though Snapcraft is not, I don't think it's installed by default on Kali, but it's pretty easy to get it installed and get this installed on your Kali machine. So I guess I would say, unless you are fine with setting up your own Go environment to pull it down, Snapcraft seems like a quicker way to do it. And that's what we have for you. Questions?
So how has it improved your overall security and investigative processes? Are there, being in National Grid, how has that impacted the work that you do there?
It's a good question. So the question was, how has this tool suite impacted the day-to-day work that we're doing? He specifically requested, how is it impacting your work at National Grid? Right now, I'm not in a position to answer your question completely, because I don't actually, I haven't spoken with National Grid about how they feel discussing those details. I can say, I could share with you some things I've heard from other organizations that have told me. Right. Well, not exactly, or not yet. But I would say, I kind of answered the question earlier when I said, so many, well, have any of you noticed that Adobe recently announced this project called Marinus? Okay, which is where they said they've been working on a project for, I think they said 2 years or something like that, where it's addressing the same exact problem, which is larger organizations or organizations with large infrastructure that are making changes just can't wrap their arms around their exposure on the internet. And this is just, and they included Amass into Marinus. So this tool is really great for addressing that problem. I would say there's so many other organizations out there facing the same challenges, where they're trying to use cloud resources more. They're using managed services, or they're trusting partners to do some of their work for them. And it's becoming hard to keep track of, where is all this? Where is it going on? Is everybody keeping the documentation up, up to date, things like that. So for blue teams, I would say that it really helps. I mean, I kind of look at this like it's helping everybody. It's visibility. That's what this is. At the end of the day, this represents an ability to see your attack surface on the internet better, regardless of what your motives are for wanting to know. You had a question as well.
So when I think it was your partner was highlighting the history tool or the history functionality, is there a way to where instead of just seeing graphical text alpha changes, is there a way to where you can have a graph that says from tape 1 versus tape 2, and you can dynamically see the changes in the visual format? Is that what I said?
So his question was, can we use the tracker's history information to then visually represent the results? And
change in DNS, that's basically 3 new DNS entries that came on. It says doing an analysis at the beginning of the week versus at the end of the week.
right? So for DNS changes, anything really. I mean, whatever caused it to move in cyberspace or pop up. So we do not right now have the ability to go from tracker changes to visualization. And it would be interesting because in order for the graph to remain linked, there'd be pieces that would have to still be in there that could still be constant or static in order to show the other pieces properly. Excuse me, you couldn't just do it off of the changed nodes or elements. So that's an interesting idea. It could be done in the future. Probably it just require a little bit more work.
Wondering how large the data set you need for that Markov analysis to really, I mean, like 100,000.
Yeah, it's a good question. So his question was, how much data do we need to start seeing for the Markov models to really kind of kick in and show some results? And it's a hard question to answer exactly. I haven't done enough work with it to say, oh no, I know it's always 100 or something like that. But it definitely needs a larger target for the results to start popping up. Like I would say at least 100 to 200. But I mean, when you start getting to larger targets where you're looking at over 1,000 result findings, it definitely shows its quality more. I would just say, I'm sure it's more like a curve where the more you can give it, the better it can behave.
It's a noticeable improvement in the hit rate.
Absolutely. And some of the other techniques are not dependent on that whatsoever, right? Like some of these other alteration techniques. But we threw this one in there really to try to find the leftovers that aren't getting picked up by the other ones. And when it did, we were pretty happy about that. Someone else over.
Yeah. So your enumeration database, is that something that you can link up to essentially for multiple contributors?
I'm really glad you asked. I should have mentioned this myself. So his question was the enumeration data, right? Like the graph databases. He said, is there a way to link up the results with something more centralized that could be then shared with other tools or capabilities? Correct? All right. Yeah. So a shared database perhaps where others could benefit from your findings. So with the way we did these demonstrations today for you, the answer would be no, because as we showed you, all the output was kept in that directory that we showed you what was in it. But there's implementation already, and it's being expanded right now in the project to use Gremlin as an alternative way to communicate the graph database insertions and updates and things like that, which works really nicely with Azure Cosmos DB, which has been really powerful for just what you're talking about, being able to put the data out there and then have anyone across the globe be able to get it. So the short answer would be yes. We're looking into what other methods would be beneficial or desirable to do the same thing. Anyone else? Strike at us.
I was actually also wondering if your Markov algorithm findings share those with other people.
Well, so since the findings are specific to your target, I mean, we'd have to keep it that way for them to be meaningful, or at least, I guess it would depend on how similar the target where you collected the data from is to your new target. But there's no reason why we couldn't dump the data, as you put it. Yeah, because sorry, I didn't reiterate the question. The question was, can we like share the Markov model findings for a target with others? And we could. It wouldn't really be that hard. You would just have to be careful, I guess, in where you decide to use it, since it could just as easily start giving you bad guesses as good ones if they're not trained on the data that is relevant to what you're targeting. Those are good questions. More? This is exactly the kind of feedback I love getting for this project. I mean, I get some really great ones on Twitter, on Discord. It's really been essential that I get all this feedback because it drives our future directions for this project. The bug bounty hunter community has been very very helpful, since they seem to use this a lot, and they want results. I mean, they want their time to be well spent, and they find all the problems, and they are quick to ask for more. But it's good. It's great. All right, so the question was, can this tool or tool suite be used internally at an organization? Correct? Yeah. And it is not designed to be used that way. For instance, I would say typically like Bloodhound would be used for something like that. Maybe not always, but it's definitely a good tool for this kind of work or task. But this has been designed, and I think we're keeping the scope that it is only for internet-facing assets. Like, that's the only thing it's looking for, or infrastructure. Well, if that's it, then I guess we will conclude here. Thank you.